Okay, with the problem we did before, the oak block would stay still. What happens if we change the angle? Does it still stay still? Or does it move? So, and what was the error in the previous thing? Was it a numerical typo? Was it a conceptual mistake? Was it a lack of understanding? What? We need to pay attention and think. Analyze, synthesize, think for yourself, please. Don't just copy things down. Do the calculations yourself. See if you can find the error in the last one and see if it was conceptual or just a numerical typographical thing. So, now, on this, it didn't move. Let's see if when we change the angle, something happens. You know, because if you think you're going to be in a world where no one makes mistakes, well, wrong. You need to be able to correct mistakes of other people to help them out, correct mistakes of your boss to help them out, stuff like that in the future. It's like all over the place. It's something with humans. We can't help others if we don't think for ourselves and know the way the world works and then offer reasoning to them. So let's do that, please. So here, let's change the angle to 50. And similar stuff. Now, this time, the perpendicular angle is, well, the angle is 50. And, oh, by the way, some people might write this like force of gravity, perpendicular, force of gravity, parallel, or weird stuff like that. But that's just too confusing, too much stuff here. We understand what's going on. I define it this way. We get it. It's easier. Not so much junk around there. So, and then remember, the normal force is equal but opposite to the weight. In this context, we got the block. You got the perpendicular force of gravity, and the normal force would be equal but opposite to it. R and IB speak. So that's what's going on. Remember that, please. Newton's third law, very important. So we get this. We have a 50-degree angle. Gravity's pulling down. Using the analysis we've done in some prior videos, we do this and this. And the parallel is going to be 98 sine 50, about 75 newtons. And the perpendicular, the force of gravity perpendicular to the board, which would, and the normal force would equal that. That's what the board is doing to support the eraser, because the eraser is not moving, is about 63. 63 newtons. Then the static friction can be, I'll do it over here. Static, get this out of the way. Static friction you know, if you need to write F sub S or something, I know we're dealing with static friction, but if you need to, make sure you label it clearly. So we do 0.62 times this, because that's what the normal force is equal to, and we get about 39. So in this case, with a different angle, the maximum that static friction can provide is 39 newtons, but the parallel is 75. So the eraser breaks free. The force of gravity down the board is more than what friction can hold. And as we've seen in class, those who have been in class, other people out in internet land and the real world land, when we've seen this, of course, you get the 2x4, you move it with an eraser, not oak, and the 2x4 is, I think, pine anyway. But, you know, yeah, you get the idea. You get the 2x4, you start lifting it, and then eventually the eraser starts going down slowly. You lift it more, it goes down faster, right? So here, the eraser will start moving. In this case, an oak block on an oak 2x4 will start moving. Because 75 is more than 39. Pulling on the spring pulls more. We can think of it like the spring breaks. And then we get to kinetic friction. So now we have a block moving. Okay? So now we can get to kinetic friction. We've done this on a flat surface. Now we're doing it on a 2x4. It's the same exact thing on a flat surface, but we just did some prior trigonometry first and like decomposition of vectors. We've done decomposition of vectors and equation of motion stuff. Same thing. Trig. So we get this and 75. Keep that. Then I'll do this down here. So we do 0.48 times the perpendicular. So the force of friction, kinetic. Maybe you can use like a S or a K or something if you want. I know we're talking about kinetic, so I know what's going on. But if you want to remember for your notes, maybe label it static, kinetic. We do 0.48 times 63. 0.48 times 63 should be 30 approximately. And so friction when the object's moving, kinetic when it's moving, the force of friction is 30 newtons up. So we got 75 down, 30 up. They're opposite, so the net force, 75 minus 30 is 45. So the net force down, the net force down is 45 newtons. Then we can do stuff with that. We'll do it in a different video. But now that we see it's being pulled down at 45 newtons, and so we can go on to see, using our equations of motion, with this force, what's the acceleration? If it starts a certain distance up, how fast will it be going when it gets to the end? How fast will it be going when it gets to a certain point? Stuff like that. I'll do that in another video next. So we got to this, and you know, 45 newtons. Then Newton's second law, we get the net force. Divide by the mass, F equals ma. So F equals ma. Is that showing? Yes, in the screen. So F is ma. F equals ma. And then 45 is 10 times something. We divide by m. A equals F over m. The acceleration of the oak block on the oak 2x4 is going to be 45 divided by 10, which is 4.5 meters per second squared. And we will do more with that later. Thank you.